Hello world, this is S. Gold back with another open source video demo. Today I'll be demonstrating inverse kinematics for JMonkey Engine. Kinematics is the study of bodies in motion without regard for the forces acting on them. The animation clips and tracks played by JME's AnimControl and AnimComposer are kinematic animations. These clips and tracks are entirely canned, their joint angles calculated in advance and stored with the model. For this reason, even if you simulate physics in your game, the simulated forces will only act on the model as a whole. They cannot affect the joint angles. Inverse kinematics, or IK, reverses the process. Instead of using canned joint angles to manipulate bones or joints without regard for forces, we apply forces to the individual bones and joints, and those forces determine the joint angles. In today's demo, I'll be mixing IK with kinematic animations using DynamicAnimControl, which is part of the open source Minier library. Here we have the Sinbad model doing his famous dance. If I turn on the physics debug visualization, you can see that the model is actually split. The linked bones above his waist are in kinematic mode, which is why they're wireframed in blue. And the bones below his waist are in dynamic mode, which is why they're wireframed in magenta. In order to use inverse kinematics with DynamicAnimControl, at least some of the model's physics links must be in dynamic mode. Of course, if you put all the links in dynamic mode and you don't provide any forces besides contact force, bone-to-bone connection, and gravity, then you get a ragdoll simulation. And that looks something like this. To make Sinbad stand upright, other forces had to be added. Most of these forces are generated by IK joints and IK controllers. In this case, there are 8 IK joints that hold his feet in place, and you can visualize, they're visualized with these green arrows. Plus there are 2 IK controllers which you can't see. One of the controllers generates forces to keep his hips upright, while the other keeps his center of mass, visualized by this cyan ring, directly above his center of support, which is visualized by this yellow square. There's also a small upward force applied to his hips to make him stand as tall as possible. I can reverse the force on his hips by pressing numpad 2, and now Sinbad squats down as low as possible, subject to all the other constraints he's under. I mentioned that the yellow square represents Sinbad's center of support. Currently it's halfway between his feet, indicating that his weight is evenly divided between both feet. If I shift his weight entirely to his left foot, then he'll lean left. Notice how his center of mass is still directly above the center of support. If I shift his weight entirely to the right, he'll lean right. The same principle applies when Sinbad is standing upright. Pressing numpad 9 shifts his weight to his left foot. Numpad 7 shifts his weight to his right foot. The ability to shift the weight from one foot to the other is a key element of walking. Walking is the next item on my checklist. In order to show that these techniques work in general, I'll quickly run through the same sequence on the 5 other bipedal models that I have lying around. Alright, here's Jamie throwing punches. Now as a ragdoll. Now standing up again. Now squatting down. Lean left, lean right, back to center, standing up, lean left, lean right, back to center. Now here's Odo. Odo is building his biceps by performing bicep curls. There he is as a ragdoll. Back standing up again. Squatting down. Leaning. Standing up, leaning. And here's the ninja model. He's waving his katana up and down as a ragdoll. Back to standing. Squatting down. Leaning. standing, leaning. Here's puppet model doing her wave. There's a ragdoll, standing again, squatting down, leaning, standing and leaning. And finally, here's a make human model, basically standing idle. As a ragdoll, standing again, squatting, lean left, lean right, stand, lean left, lean right. In closing, just a reminder, the Minier library is open source. The source code resides in a GitHub repository under my GitHub username, which is Stephen Gold, STEPHENGOLD. The demo app resides in the same repository, and its file name is balancedemo.java. This is S. Gold signing off.